So now we're going to practice integrating sine and cos squared. Alrighty, so the first one, A. We want to find the primitive, really, of sine squared 3x. Okay, now you can learn what to do, but let's derive it first, like derive the substitution. So what we're going to say is that we go back to our identity. We know that cos 2x equals cos squared x minus sine squared x. Right, but nowhere there can I see a 3x, so we've got to fiddle this. So this is a double angle. Whatever's here is double what's here. So if we want a sine squared 3x, which is exactly what we want, well, then let's match it up. That'll have to also be a cos squared 3x. And over here will have to be a cos 6x. That's right, double. Okay, now we need to make sine squared 3x the subject, but we need to change this as well. So cos 6x equals 1 minus sine squared 3x minus sine squared 3x. And you might be asking why we have to change this cos squared 3x. Well, if I make sine squared 3x the subject and I substitute, I still cannot integrate cos squared 3x. There's no rules for that. So it all needs to be in terms of sine squared x if we're integrating a sine squared, and all needs to be in terms of cos squared if we're integrating cos squared. Okay, so if I keep going, cos 6x equals 1 minus 2 sine squared 3x. Make sine squared 3x the subject. And divide by 2, and this is what we're going to substitute for. So that's a half minus a half cos 6x. Alrighty. Now if you compare it to what we did in the previous video, we found that sine squared x, the substitution, is a half minus a half cos 2x. It's an x. Cos 2x. So you can learn how to fiddle the substitution, but I wouldn't learn the actual integral. I'd start at this stage and integrate. So what normally happens is, if you compare them, you know the halves are there, and it's a cos something x. And it's always double, but, whoops, a daisy. That is always double this. So I could have written straight away that sine squared 3x, and just follow the pattern. It's a half minus a half cos, and I double the x, so 6x, which is what I've got down there. So you can learn that. So what I'm saying is, if this was sine squared 10x, then this would be sine squared 20, cos 20x. Okay, you just double it. So we haven't integrated yet. So we need to integrate. We'll find the primitive of a half minus a half cos 6x dx. Okay, and the primitive of that is a half x. Now, what do we do for trig? We say, what's the integral of cos, firstly? Well, the integral of minus cos is a minus sign, but I'll leave a little space for the number. And I rewrite the 6x, and I put a plus c. And then we need to divide by the derivative of 6x, which is 6, and we've also got a half there. So 6 times 2 is 1/12. So that's the integral. But I wouldn't suggest learning that, because sometimes you can mess up the numbers. Let's do it the long way for a little while at least anyway. Okay, B. So we start off and we write cos 2x equals cos squared x minus sine squared x, and then we figure out what we've got. Well, we haven't got just x, we've got x on 2. X on 2. Okay, so what we want to integrate is a cos squared x on 2. So let's replace that there. Therefore, that becomes an x on 2. And then on the left-hand side, you double it. So it's simply a cos x. Okay, and it's in terms of cos squared. So we need to replace that sine squared because there's no rules to integrate that. So that's 1 minus cos squared x on 2 square. So cos x equals 2 cos squared x on 2 minus 1. And then we make cos squared the subject. So what we're going to integrate is a half cos x plus a half. Okay, and as I said before, you can remember that. We know it's normally a half cos 2x plus a half, but that's when x is on this side. So now we've just halved everything. So the integral, the primitive of a half cos x plus a half is a straightforward one. So half cos x, so we put the half there because there's no other numbers to consider. The integral or the primitive of sine x, cos x, sorry, is sine x, and the primitive of a half is a half x plus c. Okay, the third one looks a little odd, and number one, we haven't done the 2-unit work for this yet, but I'm going to do it now. So I've got sine squared x with a little 0 there, and you would think, okay, well it's trigonometry, that's x degrees. However, you're asking, why doesn't that occur in every other question? Because it doesn't. And the reason is the difference between degrees and radians, which we have talked about. You only use calculus when it's in radians. There are no degrees to speak of. That's why it's pi on 6 and pi on 2 on your integrals. Okay, which we've not done yet. But I have told you that to change from something in degrees to something in radians, let's say we've got, I'll do it over here. Oops. Let's say I've got 30 degrees. To figure out what that is in radians, I multiply whatever I've got in degrees by pi on 180. And then just treat it as a normal fraction. That's 30 pi on 180, or pi on 6. Okay, pi is just pi. Pi is normal pi. So what we've got here is x degrees. We don't actually know the value of the degrees, but that's okay. X degrees times pi on 180 is x pi on 180, or probably written more conventionally, pi x on 180. So we need to make that distinction first. There's very few questions like this. I haven't seen one for a very, very long time, but it's in the course, so you do need to know it. So we're going to change that straight away to sine squared. Instead of x degrees, it's pi x radians on 180. And that's all we can use calculus on integrating or differentiating. Alrighty, so we normally start with cos 2x equals cos squared minus sine squared. Okay, but this time we need sine squared pi x on 180. So we also need cos squared pi x on 180. Put a minus in there. And convention has it that we double what's on the left-hand side. If I double pi on 180, that means timesing it by 2. So it's 2 pi on 180, or pi on 90. Looks odd, but that's how we do it. So it's cos pi x on 90 equals cos squared pi x on 180 minus sine squared pi x on 180. It's love living in Mascot with all those planes, can you hear them? Okay, now go back to the original. We're integrating the sine squared, so we need to keep that sine squared and replace that one. So it's cos pi x on 90 1 minus sine squared pi x on 90 minus sine squared pi x on 90. They should be coming, oh sorry, on 180. Oops. 180. 180. These should be becoming familiar now. So we've got cos pi x on 90 equals 1 minus 2 sine squared pi x on 180. I'll go to the next page. So I'll make sine squared x the subject, which is 1 minus cos pi x on 90, and then we'll divide by 2 as normal. So remembering what the structure is would be helpful, saying something like this, where this is a bit bulky. Okay. So if you knew normally what sine squared x substitutes as, which is a half minus a half cos 2x, then all you've got to do is double that x from here. That does make it a fair bit easier. However, there's no harm in doing it the long way. So it's a half minus a half cos pi x on 90. And we're going to integrate that. So it's a half x minus. Now, the integral of a minus cos is a minus sine pi x on 90. And then we've got to get the derivative of pi x on 90. So that's just pi on 90, that's a number. And we need to divide by that, so we need to invert it. So the 90 is going to be on the top, and the pi is going to be on the bottom, and the 2 is also on the bottom. So it's 90 pi 2, or 2 pi, plus c. So I'll just fix that up. So it's a half x minus 45 on pi sine pi x on 90 plus c. Don't see it as too complicated. All I've done is change the degrees and then apply the same rules. So I'll just rewrite that. Cos squared pi x, no, not squared,